All right, welcome. Today, we're becoming detectives. But get this, our crime scene isn't some dusty room. Nope, it's the entire history of our planet. And we are on the hunt for clues to a mystery that's millions of years in the making. I mean, really think about that for a second. We can't just pull up a video of the Jurassic period, right? So how do we have any idea what ancient forests looked like or what kinds of plants were growing before the dinosaurs even showed up? How do you solve a case with zero living witnesses? Well, the answer, believe it or not, is fossils. And these aren't just old rocks, you know? They are like perfect little snapshots, these intricate imprints of life from a totally different era. They're the fingerprints left behind at the scene, scattered all across time, just waiting for someone to find them. But reading these clues, it's not simple at all. It takes this really unique skill set. You've got to be part biologist, part geologist, and yeah, even part historian. You need to know how to look at a fossilized leaf and somehow see an entire ecosystem. And that brings us to our detectives, paleobotanists. Paleobotany, that's the official name for this incredible field. It's literally the science of recovering, identifying, and studying plant fossils to piece together the grand story of our planet's past. So, now that we've met the investigators, let's take a look inside their evidence files. What exactly are they looking for when they're out there in the field? What counts as a clue? And wow, the range of evidence is just vast. We're not just talking about fossilized trees or flowers. Paleobotanists are studying everything from the very first plants that ever grew on land to marine life, like algae, and even ancient kelp forests that built entire worlds underwater. You see, every single fossil, doesn't matter if it's a giant fern or a microscopic grain of ancient pollen, it's a piece of a much, much larger puzzle. And the mission for these scientists is to fit all those pieces together to bring the story of ancient life into focus. So, how do they actually do it? Well, like any good investigation, their process is super methodical. It all starts with recovery. That's carefully digging fossils out of layers of rock. Then comes identification, using all their expertise to figure out exactly what ancient species they found. And finally, there's the study, where they analyze the fossil to unlock all the secrets it's holding. This is where it gets really exciting. I mean, after all that careful work of digging and identifying, what's the payoff? What are the big reveals that these ancient plant clues unlock for us?
It is nothing short of time travel. Seriously. Through paleobotany, we can visualize what these ancient landscapes looked like with incredible accuracy. We can literally see the first forests spreading across the land, built by plants like Archaeopteris, a plant that changed the actual atmosphere and paved the way for life as we know it. It's like we can stand right in the middle of a primeval swamp that hasn't existed for 300 million years.
And these reconstructed worlds give us so much vital data. Scientists can trace the entire evolutionary family tree of plants, all the way from simple mosses to complex flowers. They can analyze past climates just by seeing which plants were thriving. And they can map out the biodiversity of whole ecosystems over millions and millions of years. Okay, so you might be thinking, that's a really cool history lesson, but what does it have to do with me right now? And you know what? That is a totally fair question. Turns out, looking into the deep past is one of the best ways to understand our present and our future. Get this, by studying how plants responded to massive climate shifts millions of years ago, I'm talking intense heat waves, ice ages, the whole shebang, scientists can build much better models for what might happen to our planet as our climate changes today. The past is basically a playbook for the future. And that leaves us with one final, really important question. These plant detectives patiently digging up clues from a world we'll never get to see, are they doing more than just solving an ancient mystery? They might just be finding the very knowledge we need to protect our own world. What do you think? It really makes you wonder.